We are heading into the Fabrisonic booth here at IMTS 2024 to talk with CEO Jason Riley about some new products that they are offering with their welding tool, interesting applications with graphite, and to learn about some special applications that they've done in the industry. Let's go in there to learn some more. We are here at IMTS 2024 in the Fabrisonic booth with Jason Riley, CEO of Fabrisonic, talking about a couple new applications and tools that they have and they're featuring here at the show. So Jason, take it away. Let's start with the welding tools and the new product that you guys are going to be offering on the welding side.
Yeah, so Fabrisonic has a number of capabilities. We have three sizes of our welding tool or sonotrode. Our largest one is a 20 kilohertz system. You can see the sonotrode is fairly large, as a 1-inch weld face. We've scaled that down for a few applications, most of those welding and space applications. So a couple of years ago, we brought online our 30 kilohertz system. This is about a quarter of the size of the 20 kilohertz system in terms of the weld tool, or the sonotrode. And then recently, we actually developed this 35 kilohertz system, which is again about an eighth the size of the 20 kilohertz system. And this one is specifically for a welding and space application. So we continue to innovate and continue to package the system smaller and smaller for customers' requirements.
And just because you're talking about space, I know in space you guys are working with a lot of sensors. With the ultrasonic welding that you're doing, why are you guys able to embed sensors so easily?
Yeah, so there's a few things of why somebody would want to weld in space. There's a lot of manufacturing needs there, a lot of science and research that can happen in space. What makes us unique is a couple of things. One, we're not using powders, we're not using laser, and our systems are fairly low power in terms of their requirements. Another aspect that's unique is that our process here on Earth, the ultrasonic scrubbing process, breaks up the oxide layer. So every metal on Earth develops an oxide layer that inhibits bonding. So one of the things that our process does is it breaks up that oxide layer and creates a solid state bond. That would be fantastic for an application in space, because in space, oxides can't grow. So additionally, we're a lower power requirement. Our 35 kilohertz system literally runs on a 110 power supply.
Wow.
So other high powered lasers just simply can't do that. Also, we're not working with powders and other things that in low gravity or no gravity would be a problem. Our feedstock is traditional commercial off the shelf foils. So it's perfect for an application where you need to fixture it down, and you don't have gravity and those kind of things. So those are some of the reasons why we would want to develop a system for welding in space.
Awesome. And then moving on to what you guys are doing with graphite. I know you had mentioned it's a fine material, can be difficult to work with. How are you guys utilizing your process to create a better application with the graphite?
Yeah, so one of the things that companies and industries are trying to do are take advantage of what are called superconductors or high performance materials. And those go from true electrical superconductors that operate in extremely low or extremely high temperatures to more thermally conductive materials. So this part in and of itself doesn't look extremely important. It's just looks like a piece of aluminum with some copper bonded to it. But inside this is embedded a high performance thermal conductor, which is a graphite material. Most superconductors are very, very fragile. Graphite's a fragile material. The superconductors that we work with are kind of a ceramic-based superconductors. Those are also fragile. So one of the things our process allows us to do is embed materials into other materials. Okay. So we can embed fiber optics, we can embed strain gauges, we can embed thermocouples. We can also embed thermal or superconductors or high-performance thermal conductive materials into things like aluminum or coppers. So you're protecting the superconductor or high-performance material, and at the same time increasing the conductivity of the substrate material that we're bonding it to or embedding it into.
And with this whole process, you guys are not using high heat to join the metal.
Yeah, so our process is a low temperature process. So when we bond one material to another, unlike fusion-based processes where you would create intermetallics or you would get things like diffusion, our process doesn't do that. So our process gets to maybe 200, 250 degrees C for a couple of milliseconds. Once we're done welding, you can literally touch the part. Wow. And you're not going to get burned or anything like that. So
very neat. And then lastly, just to wrap this up, is there any special projects you guys have recently worked on, especially in the automotive space, that you'd like to talk about?
Yeah, so this is publicly known. For the last few years, we worked with a Chicago-based manufacturer called Wheel Tool Works. We designed and built custom machines with them and made in 2023 35 million parts for the electric vehicle battery industry. So we can do, our platform machines can do what we call high variability, low throughput, so a lot of boutique custom applications, or our process is highly scalable to fully automated, high production, high volume type applications.
And you guys are able to do all of that at your facility in Ohio?
Absolutely, yeah. We have a small team, but we pack a big punch.
All right, good stuff. Well, Jason, thanks so much for being with us.
My pleasure.
And if any of our viewers want to reach out to you to learn more about what you guys are doing, where can they reach you at?
Go to www.fabrisonic.com, reach out to us via our applications review button, and you can contact us via that.
Sounds great. All right, thank you guys for watching, and be sure to visit the Fabrisonic booth here at IMTS 2024.